Basics of Programming, ICSE Class 8, Part 1. Need and features of a programming. A program should be simple and easier to understand and implement, which makes testing and debugging easier. So if you make a program for a particular problem to solve, then if it is easy, then it will be easier to understand. And testing and debugging and finding out and correcting the errors will be much easier. A program should be easily readable with the help of indentations and comments. So if you do programming, we will be encounter a lot of brackets. So if you keep the brackets in particular order and keep the indentation or the alignment of the brackets in a certain way, then it will be easier to read the program rather than keeping the things in the same line. And commenting is a very good uh, option that to particularly understand what a particular block of coding is doing. Suppose you have developed a piece of software and you have encountered some errors. So you have to read again the program which you have developed a long time back and find out the errors. So at that point of time, it would be naturally you will not understand what you have written. So if you had commented the certain parts of code with what the program is doing, then it will be a lot easier to debug and find out errors and maintain the code. A program should be efficient so that it consumes less amount of memory. So if a program consumes a less amount of memory, then it will be heavier on system and the CPU time. And CPU time meaning that the number of times if the program is being run in the CPU. So the CPU means the processor runs. So if a piece of software consumes a lot of RAM, a lot of CPU time, so basically it will heat up the device and use more current and lead to more heat exchange and more power draw, which will result in a less amount of battery life. So if you develop a piece of code which is very efficient, then it will be a lot easier for the program to run and in small and low power devices. A program should have generalized nature so that it should not depend on fixed set of data. Generalized meaning that the data which is being passed inside a program should not contain a certain amount of data. Suppose a compound interest program you have made, and the amount of the interest or the value which you are supplying just takes only integer values. Integer values means non-decimal values. So for that reason, so if you enter suppose 1.5, so it won't take that. So to make it generalized, we need to add some kind of features so that the program works with different kinds of data values. So this is generalized. A program should be platform independent so that it works on most operating systems. Platform independence means that if your program runs in most probably all the operating systems available, which is being mostly widely used, then naturally more people will get access to it and more users you would have. Steps for writing a program. A programmer needs to analyze a problem first, which must be done to test the problem with different set of sample data. So when you develop a program for a certain kind of problem, you need to first understand that what you need to do with the problem, and then apply certain amount of algorithms and understand that what is the desired output. Based on desired output, you will then do the further step, the next step. After analysis is done, the problem is to describe to understand it better, so that a clear idea of the output is gained. So if you have a clear cut vision of what the program is or what the problem is needed to be addressed, then if you describe the problem by breaking down into smaller chunks and 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 finding out that what are the reasons that this program is getting complicated, and you find out the way to solve the program, then the program writing will be much more easier. A proper algorithm should be selected to solve the problem, to execute the problem in the best efficient way. Algorithm means we have already studied in the previous videos that algorithm are the steps to solve a particular problem. So if you there are a lot of approaches to solve a problem. So if you find the best way to solve a certain problem, then it is your algorithm. That algorithm then you would apply it so that the program becomes much more easier to solve, and complicated logic must be avoided as much as possible. So if your program has a lot of moving things around and thus making it a lot more complicated, so a complicated logic is much more difficult to implement in real life. So a complicated logic must be broken down into smaller chunks and must be avoided as much as possible. The last step is to implement the algorithm and implement whatever you have analyzed from the problem, and implement that into using desired languages like C++, Python, Java, whatever you may like, and to make sure that the software should be user oriented and much and must work in different kind of platforms like Android, iOS, Windows, these kind of stuffs. So what are the how then we will understand that how to increase the efficiency of program. So there are two basic requirements to increase the efficiency of program. First, to decrease the execution time, and second, the decreasing the memory requirement. So what are the steps we can do to decrease the execution time? Basically, reducing the execution times means that running the program much more faster and making much more optimized so that it can run in different kind of devices with low RAM and low CPU. So selecting proper operator while using arithmetic expressions. So if you have a suppose you have a quadratic equations like ax square plus bx plus c equals to 0. So suppose you have a quadratic equation and you want to solve using the system using a programming language. So if you try to do this, you need to use the best process or best algorithm to solve them. So if you follow a particular piece of program and solve them with a particular algorithm, you will see that you will need less amount of operators to solve that we use while dealing with any kind of arithmetic expressions. Minimizing the number of operators while using the arithmetic expression. So minimizing the number of operators means to reduce the number of brackets, to reduce the plus minus and other symbols, so that the program does not stacks much amount of that in the memory. In some expressions, if some expression are repeated, suppose a compound interest formula is you have stored in a variable, it is much more easier to store in a variable than repeating the formula, because if you repeat the formula, there is a thing called loc means lines of code. So if you increase the lines of code, then basically the program will increase in size. So it is better to store the expression or the formula in a particular variable and use that variable as a function holder, and using that function you can use different kind of ways. Then function and procedures. So if you use function, if you suppose make a certain kind of function to solve a compound interest, to find out the number of primes. So if you make the logic modular, then you can use the logic multiple times in throughout the different parts of the program, making it much more efficient. In now nested loop. So we have not talked about loop, but we have definitely talked about in some kind of loop in the algorithm and flowchart chapter. That but we haven't talked about nested loop. So loop means that to repeat a certain task multiple times. So it is in computer terms we call it as iterations. If you have two loops inside one loop inside another loop, the outer loop is known as the which controls the which dictates the how many times the inner loop should run. So the outer loop should have lesser number of iterations than inner loop, so that the CPU time is greatly decreased. Then decreases the memory requirement. Sorting algorithms should be used shortest algorithm like Dijkstra's, then Floyd-Warshall algorithm. This kind of algorithm should be used for decreasing the memory requirement so that we can predict the closest number of points. The number of variables should be minimized. So suppose variables are what? Variables are basically memory locations where we store certain values which are dictated by the data types. So if you increase the variables unnecessarily, then the CPU during a runtime process, the compiler will give memory to each and every variable. So when the compiler gives space to each and every variable, it consumes some amount of RAM. So if the variables are not doing anything, the compiler will just do just as just as it works. It will assign some memory to the variables and will just keep on holding it until the program closes. So it is quite inefficient. So we should just use the variables which we need. Variables that store some constants to display during the output should be avoided. Constants are values which stays same throughout the entire program and cannot be changed. So suppose 3.14, we can do that for single purpose, but multiple times we are calling the constant as variable. It is quite frustrating and for the compiler to assign some memory, and in the long run you will get crashes. So to avoid these crashes, we need to keep on checking that the constants are used in the minimal way only. One may select a particular data type to store data that requires lesser number of bytes. So it is quite, suppose you need a value of 3.14, which is quite small, and then you selected a double, which is a double is a kind of data type which stores much more point values than a float. Float is also a data type. So float is a data type which stores um, point values. So it is so 3.14 is quite small. So if you store that in float, it will be quite much more efficient than double, because double stores uses much more data. So unnecessary using the data type and calling it and using the memory location spaces, it's quite harmful for your system only. If the requirement of a variable is finished, it may be reused rather than taking a fresh variable. That is, suppose you have taken a loop, suppose you have to doing a program and you have used a certain kind of variable for executing that task. After execution of task, the variable is used for nothing. So you can use the same variable by reusing them without declaring a new variable. This is the end of part one. We will be releasing the part two very soon.